CS ఎట్లుందా?
Good evening, everyone. I hope I'm audible. Can you hear me,
Yes, sir,
please, in the response?
yes, sir, you're audible.
Oh, okay. Thank you. Let me first share my screen. My screen is now visible, right?
Yes, sir.
Oh,
Yes, sir.
yeah. Okay, so we are in week 10, and tomorrow you have exam. So this week you have covered. Hello. Who is this speaking? If you are not, if you don't have any question, please can you mute yourself? I don't know who is this person speaking. Okay. So this week we have studied graphs. Okay. So in graph, you saw directed graph. Directed graph, then undirected graph, then you saw leveled graph. Okay. Now these are different graphs. So how a graph looks like, you'll be having some nodes. Say this is node A and some node B. They'll be connected via something called edge. Okay. So sometimes it is there will be some arrow, so which is directed graph, and if there is no arrow, it is undirected graph. Okay. Uh, so like sometimes it is very important to also mention like what is the cost associated with this edge. Okay. So as in for the lectures, professor used train data set. So there are many data set. For example, you can take a example of internet in computer networks, where when you communicate, sorry, what is this from? Okay, so if you yeah, I'll do. I'm just summarizing what we saw today. PA session will be. Sorry, what leveled and what? Someone asked leveled and undirected. Okay, no, leveled, not level edges, because if we have graph is labeled, then all the edges will be labeled, right? So we generally call label graphs. So labeled means like for this edge, you'll have some values. Okay. So one example I can give you is that in the computer networks, your information is passing from one place to other place, right? Say from India to USA. Okay. So your data will be going, but how it is going, there are different paths which can be followed. Okay. So these paths will be associated with some value. So this can be the latency. That means how much time it takes to transmit the data from here to here. So these are the values. Okay, we saw this. After that, you have this. These are the graphs. Okay, but this is for visualization. You can uh, see the graph. You can uh, do lot of things, like you can analyze minimum number of edges required to go to some particular node and others. But how to actually represent in computer? Okay, for that we saw is called adjacency matrix. Okay, so have adjacency matrix. So adjacency matrix will be like this. Like your general matrices where you have values 0, 1, something like that. Okay. So it will be zeros and mostly zeros and ones. But for a labeled graph, it may be associate these values may be your that that cost this, say for example 10 something like that. And mostly these diagonal values will be 0 because uh, like here, rows and columns are your all nodes. So a node cannot be connected to itself. I mean, that is the convention followed. Okay. So, I was mentioning this to just refresh and nothing else. So we'll solve PA questions today. Uh, that, okay.
So here the term labeled and weighted are the same, is it?
Sorry, label and
Weighted. The weighted graph and the labeled one are the same or it's entirely different? Because
Wait, you see, weighted graph is used in data structure concept, I guess, but here only labeled term is used.
okay.
Mm.
Because I think in
So,
one of the sessions that one of the instructor was using the term weighted. So I was wondering whether I missed something that maybe whether these are interchangeable terms that they use or
mm,
they are entirely different. That's the reason I'm
okay,
asking.
so these the cost associated with each age, say this is 105, this is called weights. Okay,
Ah,
these are your weights. So maybe he wanted to say uh, label graph and weighted graph. So both are same.
okay, thank you.
Uh, Let me open the practice assignments. Hello, sir. Hello. Yes.
Yeah, sir. Sir, please tell me again adjacency matrix.
Okay. Adjacency matrix.
Yeah.
Yeah, adjacency matrix is just how to represent these graphs in your computers. Okay. So this is just for representation. Like you are writing some nodes, some edges. You can see how well they are connected. Okay. But somehow you need to store this to your computer, right? Or you have to represent them in some way. This is not actually the correct, I mean, this is good for visualization, but not for storing purpose. So for that, what we do in computer, we actually, if you say this is your graph, say you have three nodes, they are connected somehow they are connected. I mean, let's not consider this direction. Okay. Then what you'll do, you will create a matrix. Okay. You create a matrix where your rows will be, say, if it is 1, 2, 3, and 0, 1, 2. Sorry, it will be 1, 2, and 3. Okay. Yeah. One more thing. In data structure, actually, I mean, in as the data structure terminology, this labeled and weighted graphs are a bit different in that terminology. It's like labeled means there's some name associated with the node. Okay, node itself. Like here we are mentioning 1, 2, 3, these things. And weighted means this weights for each age.
Okay.
Okay. But here, professor used a label for these ages only.
That
Okay.
was the reason I was asking. Because as I told you, in one of the sessions, it was used the terminology was a bit confusing.
Okay. Okay.
Thank you.
Yeah, actually, the term weighted is used in Maths 1.
Sorry, where?
The term weighted graph is used in Maths 1.
Yes.
Maths 1.
Yeah, Maths 1.
No, I'm also talking in CT itself. In one of the sessions, they were using the term. That's the reason. Okay. Now it's another confusion. It's like we have more or less the same kind of topics dealt in all the three subjects. So that's also interchanging there. Yeah. Thank you.
Okay. So yeah, coming to adjacency matrix. Now these are your rows. Okay, your columns will also be 1, 2, 3. We'll name them, and now you'll see. You'll say whether this node 1 is connected to node 1 or not. Of course, since this is the same, usually people say 0. People put 0 here. Okay, and then 1 to 2. If there is an edge, okay. If there is an edge, you'll put a 1. Okay. If there is no edge, we'll put 0 like that. So for example, here, let's now consider there's an edge like this. So here is another edge. So from 1 to 2, there's an edge. Okay. So this will be 1. Okay. From then 1 to 3 is also there's an edge. So it will be 1. After that, 2 to 3, there's an edge. 2 to 0, there is no edge. So 0. And 2 to 3, there is an edge. Then 3 to 1, no edge. 3 to 2, no edge. Okay. So maybe these values are not aligned, but you can understand. Okay. So adjacency matrix is just a representation of your graph, nothing else. I mean, later you can just look at the indices of the if you want to see that 2 is connected to 3 or not, you can just go to the index like 2 comma 3. So 2 comma 3, there is 1. So it is connected. Okay. But for a graph, you can visually say, okay, there is an edge, so there's there must be connection. Is it clear? Yeah, we'll first solve the practice
clear,
assignment,
clear.
and we'll.
Before you drill into the move into the assignment part, I have the, let's say this particular 3 node that you take, if I consider this a click, the whole thing is a click, and we extend it with the other, let's say another 4, 5 nodes in the same graph, and in that case, let's say the 1, 2, 3 that you have drawn, and if you extend 2 and 3, and further down, this 2 and 3 is part of this particular click. So when I extend this graph with more nodes, So this
Okay.
2 and 3 will again become the part of the click for another block.
No, see, click means like each node is connected to each of the other nodes.
Ah.
All the other nodes, I mean. Okay. So basically, if you have any missing edge, then it's not a click.
Yeah, so that's the reason. So if I want to, if we draw, let's say for example, if you draw
Okay, you tell me, I'll draw. No
from
graph.
2
Say
to
one.
from 2 to 3, if you extend it, let's say down to yeah 1, 2, 3.
Uh-huh.
I mean the same thing. Right? If you connect 1, 2, 3 here, and
Okay.
apart from 1, 2, 3, if we extend this 2 and 3 down, let's say there is a 2 to 4 is a connection there, and 3 and 4 are connected to each other. 2 and 4 and 3 and 4. So
Okay.
now the case is if my understanding is right that 2 and 3 is part of the click with 1, 2, 3, and again it's also part of 2, 3, and 4.
2 and 3. So
Yeah.
for click, you should have this edge also. This is directed, see. So you should have these edges. I mean, sometimes people use arrows in the same line, but both are fine. So if you have these, then you are in click. Okay.
Okay, let's say that if you ask me a question, identify the click in this whole graph. So what? How should I actually go ahead with it?
You will find this is one click and this is probably another click.
Okay, so the same node, 2 nodes can be part of another click also.
Yes.
So, yeah, that's the thing, because always I see when they define a click, always I see it as an island of 3 nodes. That's based on that it was shown. So maybe
Okay.
I'm getting it wrong. So I just want to clarify this part.
Sir,
Yes, in this
yes.
instance, maybe I also have to clear this thing. Can we discuss in the next week? I mean,
Sure.
now once you said, I'm also having some doubt.
Sir, click is basically the property of an undirected graph. You cannot have clicks in directed graphs.
Is it? See, undirected. So tell me the definition of a click.
Each node are connected to each other.
Yes. So if it is, say I have this one.
If A is connected to B, then B must be connected to it. Yeah, this is undirected.
So for that, that initially our this graph was like this. Sorry, 1, 2, 3, then 4. Okay. Then we draw edges like this. We have. Then I said it is not a click. But if you have these arrows, I mean, let's draw in the same. Then see, in undirected means when they are mentioning this line, they are saying it is both way connected.
Okay.
No, let me wait. Yeah.
So that's what it will become, sir. If 1, 2, 3 is a click, it is an undirected graph, and you add 4 to it, it is also connected through an undirected graph. Then this entire graph will become a click. 1, 2, 3, 4. This entire graph will become a click. One click.
Yes.
Parthi, Madhinda, could you please mute yourself? Parthi?
Everyone, please mute yourself. If you have any question, then only.
Hemant Kumar, please. Hemant, please mute yourself.
Sir, can you mute everyone once?
कोड तो 3 है আবার তো না প্রাপ্তি সকালে
Okay. Now, those who have question, please unmute yourself.
So, if I understanding based on the conversation that we are having, so the undirected graph is it's also means it's a bidirected graph, am I right?
Yes.
Yes.
So that's a conversation. Now, as I told you, my question that the previous question was this thing, and now as you mentioned that if you draw whether it's indirect or bidirect direction, in both the case, if I understand both are same, so then it becomes a click. So it should be. My question is whether these two nodes can be part of another block. That's what is the kind of doubt.
Yeah, that I said. I mean,
Yeah.
usually it should be. It's supposed to be. Okay. I mean, you are asking that in this group, all the nodes are connected to each other, not. That is
Yes,
the
true.
clicks, right? So
Yeah, yeah.
ideally, they should be allowed to be part in two groups, but still, I'll check in next week. We'll discuss it.
Okay. Thank you so much.
Okay. Yeah. Okay. So let's go to the programming assignment part. Yeah. This practice assignment. Yeah, practice assignment will be solving today, right? Yeah. Okay. So first question is consider the following condensed version of the train dataset. There are total n stations with stations being indexed from 0 to n minus 1. Okay. So they are basically saying there are n stations and they are indexed from 0 to n minus 1. N minus 1 because they start from 0. So if we start from 1, then it will be 1 to n, but it's 0 to n minus 1. And then they're saying there are m rows in the table. Okay. So m rows in the table. Okay, yeah, the number of trains are n, but there are m rows. Okay. Each row contains information about the train that connects to stations without any stop in between. Okay, so this m is the new some other table which is like have the value details of a train that connects two stations without any stoppage in between. Okay. So this must be the m. Then you're saying, for example, the rth row tells us that okay, everyone understood the question. If you read, anyone having doubt on this question? Hello, am I audible?
Yes, you're audible.
Okay. So everyone is okay with this question. Okay, let me still solve this. Then they're saying the rth row tells us that train T departs from station I and arrives at station J after covering a distance of d kilometers without stopping at any intermediate stations. In other words, the ith row in this table corresponds to two consecutive rows in the card for train T in the dataset trains dataset. So, in other words, the rth row in this table corresponds to two consecutive rows from this table. Therefore, each train T will occupy multiple rows in this table. Okay, so basically they are trying to say that I mean a station can connect a train can connect multiple stations, right? So for that there can be multiple entries for one train. Yes. And this scenario is modeled as graph and represented by a matrix A. Each node in the graph corresponds to a station. Each node, so nodes are stations here. Assume that the value of n is already given to you. Consider the following pseudocodes. Okay. So what this pseudocode is trying to do, So it initialize one dictionary. Then while table one has more rows, read the first row from. This is the usually we show how to read data from files, file data set. Then as dot sequence number is empty. X sequence number of train. Okay, they initialize dictionary inside this outer dictionary, first level dictionary, and then they are storing the train details. So basically, they are creating this table. Then they're saying move to X. Okay, some other table they are moving these elements. Then A is create a matrix of n cross n. So here, can anyone tell me why we are creating an n cross n matrix here? Anyone, please? So, okay, so this part is creating this table. Okay. So where you have train detail, departure, arrival, and the distance. Okay. Anyone have any idea? Whatever you think.
We want to compare two trains. So
Two
that
trains, departure time, arrival time, and distance. Like that.
No, I'm just saying, yeah, fine. This matrix, why we are creating a matrix of size n comma n? This is basically n cross n matrix.
This matrix will be basically a matrix of train numbers, right?
Yes.
Then we will compare the two trains, their departure, arrival, and distance time.
Yes. Okay, so yeah, basically, as I said in the beginning, that your
Nodes are
adjacency
same,
matrix
I
store.
think.
Sorry.
Nodes are same, so we are creating a matrix of n.
Yes. So basically, at the beginning we saw that if there are n nodes, we'll have a adjacency matrix of this graph representation, where this matrix size will be n cross n. Okay, so that is the reason. For representing any graph, you need if you are using adjacency matrix. So I don't know should I tell this or not, but in data structure, basically we have another notion of saving the graph is called adjacency list. So that is somewhat related to I don't remember if it is discussed in the lectures or not. So basically, what happened? It's kind of you can think you have one dictionary, and each key is one node, and this key will store only the nodes it is connected. Okay, so if you study data structures, then there you'll see why there are two different representation and which is better, which is like when to we use which. So basically, to give a hint, if someone is doing that course, then the difference is like if you are using adjacency matrix, then your matrix size will be always fixed. It is n cross n. Sorry. But if you are using adjacency matrix, then you first need to have detail of all the nodes. So your n value you need at least n values. Okay. Then you will store for each particular node all the nodes it is connected. Okay. So basically, if you have very less number of connections between node, which is also called sparse matrix. Sparse graph, you can say. I mean, basically, not all the nodes are connected to each other, or there are few edges. Okay, so in that case, this adjacency list is better than adjacency matrix. Okay, yeah. So coming to this problem. What they are doing next, for each R in rows. So they are taking one row from this matrix, and for each C in columns. So for each columns of A, they are initializing A of RC is equal to 0. Okay, fine. I mean, this matrix is again storing a dictionary with its elements. Finally, what they're doing for each X in keys. Okay, so S we have keys. Yeah, S is created here. So this S, each key they are taking from this S. That means sequence number of train. Okay, then R is equal to train dot departure. These values they are again taking departure, arrival, and train number, and finally the distance. Okay, and then R and C we know these stations, and T is the train number. Okay, so this train number they are storing D. Okay. So, yes.
R and C are starting and ending station.
Yes, stations. Okay. So now they're asking if I comma j is a pair of station, which of the following statement about the dictionary EIJ are true? It is a multiple. Okay. Let me just see. Yeah. It's distance. Okay. So let's see what are the options. Each key corresponds to train goes from station I to J without any stoppage in intermediate stations. So yeah, this is already explained in the question that this is directly going from one station to another station without any stoppage in between. So this seems correct answer. Each key corresponds to a train that goes from station I to J. It may stop at multiple stations between I and J. No, this is
But the first statement clearly says it won't stop.
sorry.
The first statement says clearly that it won't stop. Then the second statement is contrary. That it may stop. It is not.
Your voice is little low. Can you
Can
speak little
you
loud?
hear me now?
Still little low.
So sorry for that.
Is it the problem with me or others can hear?
It's low.
No, it is
It's
low.
low, sir.
It is low for everybody.
Sorry for that. Let me check my.
No, I think the probably what he's saying is that if the first option is selected, this automatically nulls out the second option, because this is what he was trying to say.
Okay. Which should not be, because this is said it is multiple choice question. So you are sure you are trying this first question? Let me try. No, for me it's working.
Yeah, it is a multiple choice question. He was saying the condition in the first says it there is no stopping any intermediate station. So second option is should not be selected because it is stopping at multiple stations. This is what Subrata was saying, right, Subrata? Sorry, this is what somebody was saying. Yeah.
Okay. So yeah, it is given in the question only. So this is will be ruled out. Then the next is the value corresponding to to key T A of dictionary is the distance between station I and J on its route. Okay. Yeah. So this is the D is where D, you can see here distance taking from here also you can see this distance only. X dot dist is the distance from the train dataset. That means it should be correct. This one. And next is the value corresponding to T of the dictionary is the minimum distance between stations I and J on its route. So that actually we cannot guarantee because it is we are not checking any condition here. So this is not a correct option. Okay, let me read again. The value corresponding to key T of the dictionary is the minimum distance between station I and J on its route. No, it should not be. So I think the first and third option is correct. So can anyone try seeing the answer?
Yes, sir, it is correct.
Yes, sir, it's
Yes.
correct.
Okay. Yeah, these two only correct, right? No other option.
Yes, sir, those two
I
only
think
correct.
if you
First and
see, okay. So then they are saying, what does the value of length of key Aij represents? So Aij stores all the train details. Okay. So that basically you can have an intuition that this Aij will be the number of trains uh, between these two stations. Okay, from I to J. So let me read the options. It is the number of trains that go from station I to J that stops at least one intermediate station. Okay. At least one intermediate station. That means, but in the question, they said there's no intermediate stations, right? In the first, you see where it was. Okay. Wait, it was somewhere
Second line.
written.
So second line.
Okay. So station without any stop in between. So that means this option will be ruled out, the first one. Then they said it is the number of trains that go from station I to J without stopping at any intermediate station. Yeah, that seems correct. It's the number of. Then it is the number of trains that go from station J to I without stopping at any intermediate station. Since the value is ij, so this is from station I to J only, not J to I. So this third option will be also ruled out. And then finally it says it is the number of trains that goes from station I to J that stops at most one intermediate stations. At most one means like it can have no intermediate stations or it can have one intermediate stations. Okay. So whereas the first one is at least one intermediate means like there can be, I mean, basically they are saying there is no direct route. So yeah, so the second one seems correct. Let me try. You also can you please
Yes, it is
try
correct.
once? Okay, where are you? Oh, yeah. Okay. So yeah, all the questions are related to this matrix only. So everyone understood this, how to create this matrix, right? This A matrix. Anyone have any doubt in A matrix? Okay. Next question. The next question is, IJmin is a procedure that accepts a pair of stations I, comma j, and the matrix A as input. It returns a train which goes from I to j, covering the least distance. Okay. It returns. Okay, fine. So they are saying Jmin is a procedure which accepts a pair of station I and j, and the matrix we have created A in the first question. Then it returns the train goes from I to j, like which is having the least distance, without stopping at any intermediate station. Okay. If there is no train connecting these two stations, the procedure returns -1. Okay. The pseudocode may have mistakes. Identify all this. Okay, fine. So here we have to find the mistakes basically, if there is any. Then this is the procedure IJmin, where I, comma j and E is taking as input. If the length of keys of I, comma j is equals to 0, fine. This condition is fine. And they are returning false. So see here, they said
-1.
yes, exactly. So they should return -1. Then next, train is equal to first of key of A, comma ij. So do you remember that list class where we have these methods called first, last, then length? There are many methods in list. So one of them is first. Okay.
First element of
First,
list.
rest, there. Okay, so it will return the first element of the list. Okay. So yeah. Then what they say, this train, and they're taking another variable called train and assign the value of the ij train. That means the first value of the train. So this value is basically the time taken by the first train to go from station I to station J. Okay. Then they're saying for each k in the row. So next they are taking now. So as of now, the error was in third line only. Okay. So keys here, keys will return you a list of the keys. So that's why they are taking the first. Okay. So in the seventh line, for each key in rows A of ij, okay, for each row they are saying distance of aijk, they're taking a variable, temporary variable, and then they're checking if distance is less than mean, your mean will be distance, and then train will be k. Okay. So then they're closing and returning the train. Let me check if there is any.
Sir, I'm not able to understand this 6 steps, sir. What is this? What is the meaning of this mean equals to Aij train? What will it store, or what will be the value of this?
Okay, so let me explain here. So if I write a procedure to find the minimum value given a list, what I'll do, say this is my list, 1, 2, 3, 4. Say this is 9, then 15, then 10. Okay. So if I ask you to find the minimum value of this from this list, what you will do? You will check that all the numbers and tell me that minimum number is 1. But how to write a pseudocode for this? So you will initialize some variable, say, let's say temp. Okay. Temp is equal to the first value of this list. Okay. First from, say this is our L. First from this list. And then you will write a loop for each item, let's say item ND. Or what else we can do? Okay, let me go this way. Yeah, for each also works, but what else we can do? Here I'll say n is equal to length of L. Okay.
So we can say for each item in rest of L.
Yeah. Then inside this we can remove the one element, the first element. Okay. No, if we say rest inside the loop, you have to take the first element.
So when we say rest, so we will start counting from 2, 9, 4, 15. We will remove that first part. Sir.
No, rest. What rest does actually? Rest will give you a list again.
Yes, ma'am. Yes, sir.
So rest will give you a list. Then here you will take. Okay, let me basically say the explain the concept. What we'll do? You will take the first element, and here you'll take each of the next element, say 2, and you'll compare with temp. If it is less, if your temp is less than the current element, say item. For example, say item, somehow it is giving one element from this list at a time. Okay. I mean, this is just to explain the concept. For item in, say, I wrote L. Okay. If it is here, the condition will be if it is if your temp is less than item, you will update your temp. Okay, you will update your temp by item because your current item is greater than the greater than temp. So of course, no, sorry, I wrote it opposite way. It should be if your temp is greater than item. Okay, then this is your this is the smaller element compared to temp, right? So you'll update, and finally your temp will be the minimum element. So let us run this procedure. Initially, the first of temp is 1, and then item will take each element from here from including 1. So, but okay, let's take 1 on. So it will take our. Let me define temp is equal to 1 and item is initially 1. Okay, so item is not greater than your temp. Okay, sorry, your temp is not greater than item, it is equal. Okay, so that's why it will not update. Next time what you will do, your temp will be updated by 2. Now this time if you say your temp
So
yeah.
basically we can assume a value for item, maximum value, suppose say 100, and then we can compare, start comparing. In that case, one will get stored over there.
Okay. So so this time your current item is not less than, I mean, this example is not very suitable. So initially I should have taken some very big value. Anyway, min is your min is storing the first value. Okay, first value of the of this from this key. Sorry, from this dictionary. Okay, so this I, J dictionary, what it says, all the trains which are going from station I to station J. Correct? That much you convinced, right?
Sir, so it is having the value of train number, or it is keeping the value of the minimum distance that train number has traveled.
Distance,
Okay,
distance.
see
It
here,
is distance.
here they're taking key
See,
of Aij. Okay, so since key of Aij is will be that
Train. Key of
mm,
AJ train.
no. First
Its value is
one.
distance.
So
train
your
with
train.
IGS stations.
Okay, let me check here.
No, look at the first matrix in the A matrix here in this earlier example. A RCT is equal to D, right? So look at the RC is a row and tree is a key and then D is a distance. So A stores the distance between RC.
Basically, ARC returns the dictionary which contains the train number, and against it, it has a distance to that.
Yeah, so key is the train
Yes,
number
yes,
and D
yes.
is the distance. Yes.
Yes. Okay. Thanks. So, so that this will store the first element. Okay, first distance. Then for each key in row, what it is doing in I comma j, distance it is taking from E of ij k. That so now okay, now see here they use the train number, so it will give you the distance associated with this train. Okay, the kth train. Okay, so if this distance is smaller than your previous mean, that means you have to update your mean. Okay, so now the current mean is no longer your previous mean. Sorry, your minimum is no longer the previous one. You have to update. So you'll write mean is equal to distance and train is equal to k. Okay. So then finally you'll return mean of j.
Sir,
But
there is an error in line 7 because in the line 5 trains we are using trains as a dictionary, AIG as a dictionary. In a trains dictionary we are taking AIG values, and in the line 7 we are considering AIG as a matrix.
okay, you come again.
In the line 5 we are considering AIG as a dictionary. And in the line 7 it is we are considering
it will also
as a matrix.
So it is
How will
Still a dictionary, sir. When you say AIJ, it will return you the dictionary. And it will the dictionary will contains the key. So for each k means for each key is in that dictionary.
No, that this EIJ will return you a a list which contains the distances.
Yes, sir.
So, but here
train
they are
number and
using
distance.
it as a train ID.
AIG will give train number, and then train number will have distances as value.
So which will be, I mean, train number and the distance will be different, right? So they should have what they should have, right? Okay, I comma j. Okay, so yeah, so this line number 3 there is a error, and line number 7 there is error. So let's
Sir,
check.
why line 7 should be error, sir? It shouldn't be, no?
No, so your first let me tell me what E of ij will return.
It will return the dictionary, which the
Train number.
No, it will return the dictionary which contains the train number, and against that you have the distance.
Yes, so dictionary with
Correct.
like train number as keys and values as distance.
Correct.
Yes, correct.
I think it should not be the case. Yeah, we can check now, sir. Can check.
Okay, let us spend some more time here.
7 is given as error in the answer.
Okay.
It is error.
You
Yes.
cannot take rows.
So what?
It's a
Why?
dictionary.
Row
It's a-
because of the row, or it is because of, I don't know. Is there an explanation given somewhere then?
The rows actually represent the trains, am I right?
Trains and distances.
Yeah.
as a-
No. Rows. I mean, for which you're saying for matrix A?
No, for AIJ returns the trains number and keys. The train number and
Of
the
course,
keys and the dictionary as well.
will return a
But we
dictionary.
cannot, that will be in the line 7, we cannot say that for each K in rows,
Shouldn't have written.
in keys, for each key is in,
Instead of row, key will come over there.
Okay,
Yeah.
okay. Yes, sir. Yes, sir. I think they are correct. It should be rather than rows, it should be keys of AIJ.
here AIJ is in dictionary,
So it's
not a
not
matrix.
returning an array, it's returning a dictionary, sir. So we have
Yes.
to use keys instead of rows. So we have to say for each K in keys of AIJ.
Yes. Okay. Yeah. Now I got it.
It was really hard to see that, sir.
Yeah.
It's a kind of VBA.
Okay. Yeah. So now line number 1 and line number 7. Okay. Yes. Of course. Thanks. I also was confused in this. Okay. So let's go to the next question. You're saying let's I comma j be pair of station, which we already saw multiple times. Which of the following statements are true after executing the pseudocodes given below? Okay, so they are first taking I to j is false. Okay, then if length of aij not is equals to 0, that means if there is any element, there are any train in between I to j, then I mean, if there is no train between I to j, I mean, there is some issue here. The break should.
If there is no direct train from
No,
I village.
that parenthesis should be here, right? After I comma j.
No, that's a condition. They are saying keys of that value of that key is not.
Sir, you are correct, sir. That there should be a parenthesis or bracket over there.
Because in keys we don't
No.
apply.
It is a
What?
condition. It is a condition.
See, when you say aij not equal to 0, you are trying to say that at position aij in that matrix, there is not, it's not 0.
Yeah.
But we are not checking that. We are checking whether that keys of aij is not empty. Whether that is the length is not 0 over there, length of keys list.
See, we are checking not the
here as of now. Have you ever saw professor teaching this kind of conditions with dictionary? So keys you will be
So we
applying
can say
the function.
we can see it in the line number 6, sir. It should be similar to that.
Okay. Yeah. So of course, see, one intuition you can use here is keys are apply on dictionaries, right? Okay. Anyway, let's go. So I to j will be true. Then j to I is saying keys of length. If there is some element not having any element for j to I, now they are checking the opposite. J to I, if it is nothing, then they'll say j to I is true. Okay. Then I both j they are assigning is equal to false, and then they're saying if I to j and j to I is equal. Okay, I to j and j both are boolean, so they that's why they are applying AND operator here. Then if I2j and J2I, I both j will be true. Okay. Yeah. So let's see what is the options. They're saying if I2j is true and J2I is false, then I both j is true. So okay. So for AND operator, let's see here how AND operator works. In Boolean logic, say you have two value have if you have A and B, which is in our case I to J and J to I. Okay. If you have two values 0 0 0 1 1 0 1 1. AND operation, how AND works is if you have 0 0, the result will be 0. If you have 0 1, it will be again 1. That means it's multiplying. You can consider this as a multiplying simply. So 1 0 is again 1 and 1 1 will be 1. So this is our I both j. Okay. So it will be 1. That means 1 you can consider as a true and 0 as a false. So it will be true only when your both I2j and J2I is true. Okay. You can see my screen, right?
Yes, sir.
Okay. So here the first condition is saying I2j is true and J2I is false, then I both j is true, which is not. We just saw. Okay. So for I both j to be true, both this I2j and J2I should be true. Okay. So yeah, again, sorry to interrupt in between. Here, these mistakes can be because some person are setting these questions, right? So we are bound to do mistakes. For example, here also you can see this is I both capital J, but here I both small j. Okay. So these kind of mistakes are bound to happen.
Here, keys are the train number or another
Sorry?
or any other. In the line 2, the keys. What are the keys? In length of keys of AIJ, what are the keys? Place number or
Ninth line you're saying?
in the line second.
Okay.
What are the keys of AIJ? Train numbers.
Yes.
Train number.
Okay.
I think
So
it
you
should
mean
be
to
that the keys are not equal to 0, but it's like the dictionary is not
No,
equal.
they're saying if the length of keys, that means they're basically
length of the
checking
list.
if there is any train between these two stations.
So it should be like the bracket should be with length keys and that 0 part should be separate outside the bracket.
Yeah, it's
Yes,
similar to
yes.
sixth line.
steps
You can see
2
the
should be
condition.
same as step 6, right?
Yes,
This is what you are saying. The bracket is
No, again, see,
step 6.
I think there is issue with step 6 also. Because after you find length, so let me go here again. So whenever you call any function, say do something, okay, or say my function, you have some procedure, okay, and do some my function, okay, whatever it may be. You will get the value of this from this my function when you close the say some variable temp is equal to my function. Okay. So see, after this closing brackets only, you will this function will be get called. and you will get the value. But here, if you see, after length also, they are not closing.
So
Okay.
you mean to say, sir, this key should get close. There should be one more bracket over there, and the entire length should be not be equals to 0, like that.
Yes, yes.
Okay.
So this is this bracket effectively. This bracket will also should also be taken inside. That is
Yes, sir. Printing mistake.
Okay. So yeah, let's go to the solutions. Next is saying if both I to j and is if I to j is true and j to I is true, then I both j is true. Yeah, that is fine.
Yes, sir.
Then they say if both ij is true, then I to j is true and j to I is true. So
Correct.
yeah, it seems correct. Can anyone have any explanation, like whatever? I mean, if it is true, then why true? Then sorry, if it is correct, why correct? If it is not correct, why not correct?
True and true will always give true.
Okay.
There's an and statement. So
If the result is true, that means the both the statement must be true because it is an and statement. We will have to.
So yeah, that means you're saying okay, we should select this one also, right?
yes.
Okay, let's see. I think it will say this is not correct answer. Okay, so the next option is if I both j is false, then I to j is false and j to I is false. This also seems correct.
No, sir. Here is another case.
No, sir. If one
When
of
I
One-
to j is true, then also
One can be true also.
both j is false.
yeah,
But see here, here when they both are false, then it is false, right?
Then sir, here is a one another case 0 or 1.
Two other cases are
Yeah,
also there.
that they are covering. They're saying in the next, I guess. So if I both j is false, then IoT j is false and j to I is true. Okay, I was saying IoT j. It means I to j. Yeah, IoT j. Yeah, so you're saying this is correct. Hello.
So, for false conditions, sir, and will not come, I think, or will come, because there are multiple cases for false condition.
Yeah.
Okay, so basically,
Yes,
just tell me which option should I select?
last option.
Last one.
Last option.
If both j is false, then I to j is false or j to I is false.
this is correct. Or because there is an or between them.
Yes, yes.
Well,
Option number 4 and last are same.
No, there is an and and there is a or.
They are not
Then
And or is it's different.
Yeah.
okay, so yeah. Next, you're saying these options will not be should not be selected, right? These three.
Yes.
yes.
Okay. Fine. Can anyone tell me more about like why you didn't? Yeah, one more time only. You already explained, but one more time. Can anyone explain why it is not chosen?
So option number 5 will option number 5 will never be true, and because sorry, 4 number will not be true because if both are I to j and j to I is false, then the train will not pass through that station.
No. It's see. They are saying it is not about train or something. This is about some conditioning, and you need to understand the Boolean operations. That
If like
this is basically
This is not
testing your
Boolean
algebra.
Option number 5. 1, 2, 3, 4. So,
Okay,
And
let me try.
statement.
Let
And
me try.
statement.
Yeah, someone is saying something.
and statement will give true only if both the conditions are true, and if even one is false, it will give false as the answer.
But
So
the
if it's
question,
false, then it can be true, true, false, false, true, or it could be false, false. So all three could happen if it's giving
Yeah,
false. But
all
for
three could
true,
but
happen.
he's asking question number 4, right? I mean,
No,
technically,
for all.
with respect to Boolean
no, but
operation,
we cannot assume, right? If it's false, then it's only false, false. It can be
no,
true,
it
false
is not
also.
No, it is.
assumption.
See,
It
it
is
is not
it is
saying.
Boolean
It is
operation,
not.
right? Whether this statement is true or not. If it is I to j is false and j to I is false, then obviously
It will give
I,
false,
I
but
Yeah,
if
it
we
will
know
give false.
that it's false, then
See,
we cannot assume that both will be false.
okay.
Here is
Let me
multiple
interrupt.
cases,
Here.
then we
See.
consider all case.
no except one, then logically all 6, all 7, all 6 except
Yeah.
one.
Okay.
No, but if it is
See,
telling that
let me
both is
explain. Let
given,
me interrupt.
Sir,
Let me interrupt.
is it the
What I was
contra?
asking.
Is it
See,
the contrapositive statement?
no. See, what here they are trying to test your Boolean algebra logic. Okay. So here, see, if you see in the fourth option, it says if both ij is false, then iotj is false and goti is false. It is not saying only this condition. It is saying one of this condition. Okay. So it seems to be correct. I mean, if this condition is in the this sentence, this part of this sentence is in the last then it is correct.
If any
But
of I to j
now
or
it is not correct. Now it is not correct just because if many of you are very close, but if I mean, according to your explanation, if this part of the this statement is if I attach in the end, you'll say it is false. But at that case, it will be true. We should select this option. But now we should not select because given it is false, we cannot say which condition is actually satisfied. Okay, among these three, anyone can happen. So it's like knowing from the future. So you'll not be able to know. But if this condition, only if this condition, if they wrote in the last, then it should be selected. You should select this option.
Yeah, if they would not have given us the last option, which is more correct than the upper 3 option. If last option was not given, probably these 3 options would have been the candidate for selection.
No,
but the last option is more correct.
The reverse if was given, then it would have been selected.
Yes.
No, here not. It is not about like preference, more preference. What I'm basically trying to say is, you can see my screen, this PPT, right? Let me add. If I change this, if this is false, then can anyone tell me, should I, if this
This is
condition
true.
This is true. This is true.
Yeah. I mean, given I to j and j to i's status, we can definitely say what is about I both j. Okay. Yeah, thank you.
And if we take this as reverse order, if both I and j are false, we cannot make a prediction about what if I and j are false or if it is true. Same for a j to I also. But
Sorry, can you come again?
If
See,
we take
you talk in terms of I to j and j to I,
yes,
not I
yes.
and j.
If we initially consider this I to I both j is false, then we don't have this independence of saying that I to j can be true or j to I can be true. We will have to, according to this statement, we will restrict ourselves to only false only. But one of them can be true. That possibility will get, sir, it will not
yeah,
get
all
considered
three
over.
can happen.
One of them can be true, but we will not consider, it will not get considered over in that case. In this case, that's why I think so. We are
Okay. Then coming to the next one. Here, using some pros is a procedure that accepts three parameter: a train, a station, and a matrix A that was computed in the previous question. Which of the following statement about the return value are true? Okay. Again, it is the multiple choice question. So some process is accepting three parameter: train, station, and matrix A. Okay, so this matrix A is already calculated, so they are passing this. Yeah. Now let's see what is happening in the procedure. It's taking three parameter here: train, station, and A. For each R in rows, that means it's taking a dictionary of dictionaries. If is key of AR and station, comma train. So is key actually checks if the particular key exists in a given dictionary. Okay. So they are checking if this train is in this dictionary, then they are going inside. And for each C in column, now they are checking each columns. If is key of A station, comma C and train. Now they are saying if between the station and all the stations they are checking basically. If the train exists, they'll return false. Okay, and after the execution of this entire thing, it will return it will return true. So they are checking one row only. Let me see. Yeah. So yeah, they are effectively checking only one row. They're not checking multiple rows. I hope you able to follow me, right? Like they are checking only one row. Okay, no. See, if the train is a part of this any row, they are returning. If it is not, they are checking the other rows also. You understood, right? Okay. So next, so basically, let me think what it is trying to do is if and for which at station to some yeah. So basically, let me just think for a few seconds. Is keys plus taking again finally they are returning false. That means if the train is one thing we are sure that if the train is not exist in the data set, then they are returning false. And on the other side, what they're saying, if R2 station or any station to other station, if this train is going, then they're going inside, and then they're checking if that station to some other station, if the train is going, then they're saying false. That means here if the train is going somewhere else, then again, then they're saying false. That means the train should be to return true. This train should be uh, mm, okay, let us read the options. We'll get more intuitions. Suppose return true if station is starting station for train. Okay. Okay. No, it cannot be starting because they are checking R2 station. Okay. So some process return false if station is starting station for train. This also we cannot guarantee. Some process returns true if station is ending station for train, which should not be. Let's see what is the next option. Some process return false if station is the ending station for train. Yeah, this seems correct. Let me see it is multiple or not. Yeah, it is multiple choice question. Yeah, so are you convinced that this about this option that return will false if station is the ending station for
So shouldn't it be B, sir?
No, it will give
okay,
true.
okay. Okay, let me check. Yeah, if it is some intermediate, then it is returning false. If it is some intermediate point, so let us check if there is return false. If starting point, you cannot guarantee it.
So
You
when
don't
we
have
say
No.
there is a train from R to station STN, then we are checking inside whether that's from that station to another station, the same train is the has a start station and destination station. So this condition should not be satisfied. That's why I said it shouldn't be second.
no your yes your STN, which is station, is in
Yes,
the
sir.
second as
So
used
that
as
is
a
the
second
destination,
key.
sir.
So this is a destination.
Yes, sir.
So then some region false.
So it's saying
Yes,
that
because
for the destination.
Okay. Yeah. They are saying if it is
The source station words. This shouldn't happen. That's what they are trying to say. The same train should not have a source station as the destination which was provided to it earlier, which was and how to say don't know.
No. See, if you see this condition, this is we can correlate with end. So it's saying if it is going from R to some station,
Yes,
and
sir.
then that some station to some other station.
Sir, but that when you say A of STN to C, it means the STN is the start station and C is the destination for that.
Come again?
Where it is written? Where it is written like that?
In the matrix itself. That's how we create that matrix.
That's like R is given as departure and C is given as arrival, right?
Yes.
So the first part would be departure.
No. Sorry,
second
your
part
first is
arrival.
your yeah.
First
Okay.
and second.
Yes. Yeah. First is departure and second is arrival. Okay. So yeah, it is in the first question only. It is defined. It is saying if it is starting.
Yes, because A station C is like next line is false. So anyways, it
No,
will give false.
it will, yeah, next will be, yeah, this is, can we say actually? Yeah, you please explain, right? You are explaining, right? What I understood from here is that, see, the first one is saying it is going from some station R to some station STN. Okay, if it is going, they are going inside the loop, and there they are checking if it is going from that station to any station C. Okay, then it is false. That means if this station is any intermediate station.
Means it is taking direct test. If the any train is moving in a direct, it's not taking any stop in between, right?
It will return true if there is a direct train, basically.
Is it?
I mean the
Just
station
false.
is.
Does it?
Basically, it's trying to say that after the last station, there should not be any other station.
Correct. So STN should be the last stations, right? This is what it's
Yes,
saying.
yes.
Yes.
It is starting from R, then it should stop at STN. It should not move from STN to some other station.
Yes.
Okay, so let's check where it is ending.
Okay.
Station is string.
So it's basically, is it checking the starting station and the end station?
No, not starting. It's checking. So see, first condition is checking given this train, is it like for each row? I mean, for each row is your one station, right? For each station they're checking if it is going from that station to this STN. This STN is given. Okay, so if it is going to that station, and then from that station to if it is going somewhere else, it is returning false. That means this, yeah, whatever you said is correct. Some of you, that STN should be the last one. But if say these conditions are not matched, that means this what can happen, that this train is actually does not exist at all. That time also it will return false at the end. Okay.
Sir, it will return true, no, sir?
Sorry?
So it will return true because after for loop there is a true state, return true statement.
No, that true
So
is
at the
after
end
the
you can
bracket.
So they are saying if the station
that
is,
condition is
if the
not
station is
satisfied,
last
then
station,
yes.
If the station is
return true.
last station, it will return true.
Yes, sir.
But
Yes.
if this train does not exist, then
Okay.
all these loops will execute, and finally it will come out to this outer for loop, and then it will return false.
Yes, I got your points.
Okay, so yeah, let's check one by one thing. So what we are saying, we are agree with that. If the station is the last one, then it will return true. Okay, so let's see where we have true. We have true here. Intermediate station. True. Intermediate station. Can anyone see that particular option? Which ending station? This one, third one. Returns true. STN is the ending station for train. Okay, third one. Everyone convinced for this?
Yeah.
The last one
Yes.
also. See,
False
last one was
starting.
false.
It will be false if it's starting station.
No, false. Not starting. We cannot guarantee because.
No, it will because R will not be there, right? R bracket station would not exist, so it will directly go to false.
So that option is here. The return false.
No,
train is
means
not in graph.
SN station, there is no station before. Like there is R bracket STN, right? So if STN is the starting station, then there will not be any R. So it will
Someone is
directly go to
interrupting.
the last
Please,
line.
can you mute yourself? Hello. Now please
Yashasvi,
unmute
say it again.
yourself.
Say it again. What are you saying?
Means in that if statement, it is that is key a bracket R bracket STN. So if STN is the starting station, then there will not be any previous station. So there will not be any R. So it will be automatically, if statement would be false. So it
But
will
does
go to the
that
last line.
If this statement is false,
It will go for
no,
each
no, no.
bracket
It will check for the next all the stations.
it will
See,
no? But
Sir,
it will.
can you create a matrix and explain, sir?
okay, let me try.
But that condition may not exist because R will be STN. So the true condition will be like STN to STN, and that will become false. It will take R as an STN at some point of time, right? Then the condition will become is key A station. Is that right?
that would not make sense, right? That the train would that would mean that the train starts from that station and then comes to that station.
Correct. So that's where it will become false. But R will not be there, may not be the case. I'm saying. I mean, in the execution, I'm saying.
No, I'm saying for the option that STN is the starting station.
Okay. STN is a starting station. Oh, there is an option for that. Okay.
Yes.
Yeah.
So then it would be false.
Yeah.
Which one it is?
The second one.
Second one.
Correct.
Okay.
Got it.
Okay. Yeah. Okay. Now I hope these are the correct answers only. Others.
There is one more.
Okay.
If STN is the intermediate station, and it will give false.
Yes, because intermediate means it is going from R
Between
to
R
some
and
station.
C.
It is from going from. So if it is going from R to STN, then it is
to
going
C,
inside.
then false.
And then here again, it is checking from that station. If it is going to C, then returning false. Okay, yeah. So that option is where? Which one?
Yeah.
Return false. Some process.
Third from the last. Yeah.
Third from the last.
This one, right? Intermediate station. Yeah. Okay. So anyone tried? Okay, yeah, it is given here. The four options. Now 6 to 7. Assume that there are n stations in the train dataset, indexed from 0 to n-1. The same thing. Consider the graph with stations as known. There is an edge from station I to station J. If and only if there is a direct train from I to J. Okay. That means they're trying to find single edge graphs. The graph is represented by the matrix direct such that the direct of ij is equal to 1 if there is an edge from I to j and 0 otherwise. Assume that direct has already been computed and direct is a non-symmetric matrix. Okay, so non-symmetric matrix because they're saying if there's a situation when I to j is possible with one edge only directly, but that doesn't mean that j to I is also possible. Okay. Then station j is reachable from I if we can find a non-empty sequence of trains that takes a passenger from I to J. Okay. In other words, J is reachable from I if there is a non-empty sequence of edges that connects I to J in the graph. Somehow it should be connecting. The following pseudocode computes a matrix B of identical dimension as direct, such Bi is equal to 1 if and only if J is reachable from I. If J is reachable from I, yes, okay, in the reverse order. All others entries of B are 0. Okay. So then they're saying there is some issue in this. Okay, no, they are asking to fill this this code block. So initially they are finding the length of this matrix. I mean, of course, this is a square matrix, so number of rows and number of columns will be same. Then B is a create matrix. Then for each B of RC. Okay, so this direct matrix is given. Direct matrix is all the like direct matrix will contain 1 at its position if there's a direct edge from I to J. B of R comma C is direct RC. Then hops is equal to 0, while hops less than n minus 1, B is equal to 1 more hop. Okay, so in the question they ask like if we can find any situation when where a passenger can go from one station to another station via multiple paths. So if it is a direct path, that's fine. But even if there is no, so can anyone tell me, like, if we have a graph of nodes and stations, then how many stations in worst case, I mean, in bad situation, you have to travel like in between intermediate stations?
N minus 1.
minus
Yeah.
2.
No, it is n minus 1 actually.
Sir, the source would be 1 and the destination would be 1 and the intermediate would be n minus 2, no?
No, so basically I was asking like how many time you have to
Okay, got your points. Got
change your route. Okay. So this is actually a very standard concept and it is proven in graph theory that if there are n nodes, you need n minus 1 edges to connect all of them. From if you have to go from one node to any other node. So more than that is not required. So yeah, okay. So here they are calling while n minus hop is n minus 1, they are calling one more hop with this matrix B. Then they are incrementing hop is equal to hop plus 1. Then the procedure one more hop is written as for each row in B and for each column in B, they are trying to do something. So this we have to find out. So basically what we have to do, then after that we have to again check for each station if it is possible. Okay, if any via any station, if we can go, then we are good. I mean, here they're checking for all the n minus 1 hops. So first we'll check with one hop. If it is fine, then this okay, what they say. Okay, anyway, they're not breaking the loop. This loop. If I mean, it's okay. I mean, our purpose will be served, but what I'm saying, they could have add one break here after once we get our desired answer, I mean, non-empty list, we can just tell, okay, no, actually, this is, yeah, of course, after this 11th line, we can check in this B matrix if it is possible that I to J is true or not. If it is true, we can break. We don't need to actually process further. You got me right. I hope you got me.
No, actually we would have to, because the procedure, one more hop, it gets the value from there.
So it will be in B, your I to J will, J1 means what?
Means if we add a exit loop, then it will just get like one or two values, not the whole thing of the procedure.
Let
We
me
want a list,
think.
not non-empty. We need all the values for the procedure.
No, see here, if you read station I to J is reachable from J is reachable from I. If we can find a non-empty sequence of train that takes a passenger from I to J. So if we find one route, that's fine, right? We don't need to check further. And see here again, they're saying B I to J1 is equal to 1 if and only if J is reachable from I. Okay, so if you once you have once you add 1, after that all the times we'll be updating this 1 to again 1 only. We will not be doing any further modification. So I mean, of course, you can check what is the if the question is what is the longest road, then also you have to do some other process in between. Okay, yeah, anyway, let me see. This is I mean, we have to check this block only. This has been asked what to do. I don't know who asked said we should be, but you are able to follow what I'm saying, right? So once you have assigned 1 to Bij, then you're done. Like your purpose is done.
Sir, but in that while loop, we don't have access to I and J, sir.
But we don't have, but that's why I'm saying now we can check here. You can write one loop and check, because checking here will take less time compared to calling this function again. Okay, because this function will be performing many other operations, and the complexity will be also be less. Like because here this is already 2 loop is written. Okay, so this is computer is really fast, but still it needs some time to execute statements. So it will execute for each row, and for each row, for each column, it will definitely do. And after that also it needs to do some proper operations, other operations. So again, that basically means, like, if you have given this direct one, this B matrix initially is direct matrix only. Okay, so that means if there is any direct edge from this I to J, okay, or basically here according to the question it should be J to I, if I guess. Yes. Okay, anyway, okay, so here if this is given, then what we can check for the next one more hop, we can just go through each of the stations and check if this station reaches to the destination. Okay, so here one more loop will come. So let's see the options. Here it says for each k in column of B, if B of RC is equal to 1, exit loop B of RC. See, yeah, from here you may can get some intuitions. If BRC is 1, they are exiting the loop and they're saying, okay, we are done. and okay. So BRC is equal to 1 means here you see,
Direct
your R and C are your rows and columns. So if BRC is 1 means these two stations are connected. Okay, so you can exit the loop. Otherwise, what you have to do, if B of RK, so this is the intermediate station. So if you are able to go to some intermediate station, that means if BRK is equal to 1, and that station to some that your destination C is our columns basically here is 1, then you will update BRC is equal to 1 and you will exit the loop, because for your current this one you updated. Yeah, so this must be true. And then we are saying, so everyone convinced for this, right? The first option.
Yes, sir.
Why the need of exit loop?
Exit loop, see, once you update this, you don't need to further check, right? Why to check further? And it's already you're convinced that there is a
No, but this is just one time, right? There could be another possibilities that the same two stations can be connected by multiple hops or other stations or other trains, right? So
so they are asking just if there is any connection. So since there is no weight is given, that means the distance is given, not given. So you cannot find which is the shortest. So that doesn't make sense. Here they are just asking that if it is possible or not. So once you find that, okay, if it is possible, you can happily exit. Is it explanation correct? Sufficient? You're not convinced, right?
no, that's fine. I'll have to think about it. Yeah, I'll take some time to understand.
No, if you have any doubt, you can ask. You didn't understood my explanation.
No, that's fine. I think I'll take a minute to process it. Thanks. Just move ahead. Yeah, thanks.
Okay. Let me come again. What I'm saying that in the question it is asked that please check if it is possible or not. So if I ask you that okay, how to frame this? Okay, let's not divert anywhere else. So it's just basically asking if there is any path from R to C. Okay, so once you again the explanation will be same only. Okay, you can check later if you further explanation. The next is saying for each K in the columns of B, they are checking if RK is equals to 1 and B of KC is equals to 1. Then they are updating this RC to 1. See here, whatever you asked, they are doing here. Okay, so they are checking for each of the possibilities. If it is possible, they are updating it. Okay, so the difference between this code and that code is just this more optimal code, optimized code. Okay, number of lines may be more, but this will be sometimes this is very crucial to understand that like balance between your execution time and this simplicity, memory. There are a lot of things you have to consider. So this code will be much more faster than this code. Okay. So this is also seems correct. Then for okay, let me check once. Column for the okay. So next one is saying for each K in rows, if B of RK is true and B of KC is equal to 1, and this is also 1, then B of RC they are updating 1. That also seems correct.
Sir, it says rows. Shouldn't it be columns?
Not exactly, because
Okay,
yeah,
it'll give
at the
it the
beginning only
same.
we at the beginning only we saw, right? Number of rows and number of columns will be
Same.
nodes will.
Mhm.
So this also seems correct. And the next is saying for k in column B, if B of k to R is true and B of k to C is true. Okay, see here, here the mistake is it should be R to K.
Yes.
You able to understand, right? The intermediate should be your K, intermediate station.
Yes, sir.
It should be R to K and then K to C. So this fourth option is not correct. Yeah, can you even try? These three are only the options. Or is there any wrong option selected? Can you even check?
No, all these three are correct in the answer key which is given.
Okay. Okay, so the next question is consider the following graph for all the case of n is equal to 5. Okay, sorry. For the case of n is equal to 5, then matrix B is corresponding using our pseudocode. What is the value of the sum after executing the following pseudocodes? Okay, so sum is equal to 0. Then for each row in B, for each column in B, sum is equal to sum of R plus C. Okay. Yeah, so they're executing, they're saying this graph is applied.
N into n minus 1 upon 2.
Sorry?
0 plus n minus n into n minus.
You're saying n into n minus 1 by 2. Sorry, n into n minus 1 by 2. Yeah, that is your saying, right? What is your n here?
N 5.
N is 5. So you're saying if it is 5, so 5, 6, 30 divided by 2 is 15. 15 you're saying. Okay. So which is not actually, because here you said, we discussed a lot that I said once I find the that if it is possible from I to J, I'll stop, but they are not stopping. So what will eventually happen? It will again check for the next number of possible hops. Correct. See, if it is possible with 3 hops, it will be definitely possible with 4 hops. I hope you are able to understand. Okay, so what will happen at the end? Everything will be this 1 1 1 1 1, and anyway it is. I mean, okay. So for all
Please
the
create a adjacency matrix for this.
okay.
5 into 5 rows and columns.
So here it is not, because it is not, the explanation is not 5 into 5. You have to add 1 25 times. Okay, yeah, your answer is correct, but it is just how to solve it.
Yeah, I understood that it is like the same ij would be there for 1 hop, 2 hop, 3 hop.
Mhm.
So that's
So
why it will be 5 times for
Mm.
1, for 2, for 3.
the graph was like this, I guess, no? 1, 2, 3, then 4. Okay. So your adjacency matrix will be, if it is your matrix, 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. 0 to 0, let's put 0. And then what it is? 0 to 1 is edge. 0 to 2, no edge, no edge. 0, 0. 1 to 0, no edge. So there it will be 0. Then 1 to 2 is a edge. 0, 0, 0. Sorry. It will be here. Let me choose. One, 0, 0, 1, 0, 0, 0, 0, 0. Okay, sorry. It will be 1. Okay. 3 to 4. Here it is. Let me erase again. From third node, 0, 0, 0. Fourth one will be 1.
The last one will be 1.
Last one, okay, yeah, last one is 4. Sorry. Okay, let me write it here only. Make it 0 and it is 1. Next will be 1 here, 0 and 0. Okay. So now from this matrix, they are applying this thing here. This yeah, all this this procedure is applied in this matrix. I mean, of course, from this adjacent matrix, they are first creating a direct graph. So if there is any direct route from this adjacency matrix is again, you can consider this direct only, because this is also wherever there is a connection, we have 1 only, otherwise 0. So if we apply the matrix, sorry, this do something procedure, sorry, one more hop procedure, you will have 111 value for all the places. Okay, 1111. So if we add all these ones, we'll have 25. So here you can see in for loop, where here for loop they are starting for each loop row, and then for each column in this B, they are adding a B of RC. Okay, initially sum is taking 0. So there are there are 5 nodes. So we have 25 different elements, and for this all 25 will be 1 1. So you'll have at the end you will have 25 result.
Explain that 1 1 1 1 1 again.
See, if in this procedure, if you see what is doing, it is first taking this direct. Okay, and then applying one more hop with B. One more hop, when you apply, it will go inside this procedure, and for each station, it will check if there is a possible that it will go either transitively or directly to that particular station. It will update to 1, right? So here you can see So for each each of the station, that columns means each stations, correct? These columns means each station. So from each station, if it is possible that it will go from R to that intermediate station and then intermediate station to C. If it is possible, then it will update to 1.
No,
So
but it is, if it is possible, we are not sure whether all the.
it will be possible because see, they all are connected in a chain. So eventually you have to you will be
Okay,
able
sir.
to
For this graph, it is possible.
For this graph, okay, for this
Uh-huh.
pseudocode.
Yes.
That's why I guess they have the hops plus 1, because we might use it in the next question.
Okay, that's a
That
good one.
hops plus 1.
Yeah, that's a good one. Yeah. Yeah.
Okay. Okay, so next question is the following pseudocode executed using trained dataset as discussed in lectures, trains, diversification. The number of key mapped to list station which the train runs through. For example, train, that means they're giving this train dataset where we have the key is the train number and all the stations it is going through. In this example, the train with train number 1 train starts progression. Okay, like how it is going. Then comnum is a function returns number of common elements between L1 and L2. Okay, so observe the following pseudocode and answer the given questions. Okay, so here do something they are first doing. Do something here for each key in train index I. So this is what they are doing for each key. For each station, they are actually assigning some specific value, index value. Okay. So then n is length of the key. CSTN is create matrix. They are creating one matrix of n cross n. And then for each T1 in the key train, for each T2 in the keys train. Okay, let me see. T1 in the keys. Okay, so for each train, basically they are doing something. If T1 not equals to T2, that means if it is not the same train, then CSTN index of T1 and index of T2 is equal to commons of trains T1. So they are passing these two lists. So train T1, if we apply, this T1 is the train number. So it will it is a list. Okay, so these two lists are passed in com number, and com number returns actually number of common this thing what said common elements. Okay, so and which will be assigned to this CSTN. Okay, so this is index of T1. This will be this CSTN will be indexed by some number. Okay, all these trains are actually mapped to some index, and then it is processed here. And finally, they are returning this CSTN matrix and index. Okay, so they are returning both the matrix and the mapping procedure. Then it is saying if CSTN ij is 0 for I not equals to j, then which of the following statement can be concluded? Okay, so there is no route between station with I and j using one hop.
Sir, I and j would be the index of train number, no?
Yes. Train numbers. Because they are mapped here, the trains with this index. It is not that a train number. It is not this one big train number.
Yes, sir. There is a mapping of that train number to some index value.
From 0 to n.
n minus 1.
Yes.
Okay, so then we are saying if it is not true, that what that means there is no common station. There is no common station. It means, I mean, it will not. We cannot go through.
Sir, first of all, the indices do not represent the station; they represent the train. No?
Train number.
Yes, yes.
So that option goes wrong by itself.
So I mean, no, but this
No,
this
it is
trains
getting the
will
values of train. If there is anything common in the list of values of train.
that means
So train would
these
have
values
station
are
as value.
these values again. You need to remember that these values are actually stations. You able to follow me, right? This values again, they are stations. So if there's any common element, that means you can travel through these stations. This okay, where I was? Yeah, this is train ID, right? This if this trains. Okay, let me think. They're passing two trains information.
It will give if the both T1 and T2 have any common stations in them.
So what I'm trying to say is CSTN is keeping track of the trains, sir. I mean, the mapping of trains. I mean, I've got index of one train and index of another train.
And how many, for that, the value is how many stations are common?
Yes, sir. So, but the option is saying that indices are the stations, which is not the case. That's what I'm trying to say.
No, it's saying there is no route between
stations with indices ing, and it should be train ing.
Actually, maybe maybe this framing of this option is correct, but what it's trying to tell is that these two things, there's no common element between these two train.
It is meaning that you
Yeah,
cannot do a one half.
Okay, so let me check the other options. There are no common trains between these stations with indices. Yeah, that is only because see everywhere there is seeing station with indices ij. So ij, of course, they are trying to say they are trying to mean trains only, but stations means because the values are stations. Okay. So if ij is 0, means there is no station in between, like there is no station connecting these two trains. So that means there are no common trains. There are no common trains. There should be common stations in between station and NG. And there are no common stations in the route of the trains with
yes, sir. That option should be correct.
Yeah, that is correct. So there is no common station with station on the route of the okay. So the next question is, assume we start our journey using a given train T. Now consider the following procedure. They should return true when it has at least one common station with all other trains. Okay, what it's saying. Then I mean we have to choose the correct option. Here they're saying we start with some train T. Now consider they should return at least one common station. Let's see. So this procedure was okay. This procedure do something. So if do something returns say a list, that means okay, from this matrix and indices they're taking initially, and then k is index of t. For that that particular index only, for that particular index means all the all the other trains for this associated with this train which have the common stations. Okay, so for that they are checking for each I in column. If I not equals to k, okay, yeah, for I not equals to k, because they are not checking with the same train, and cmat of ij is equal to 0, return false, or otherwise return 0. It seems correct. And then saying count is equal to 0 for each t2 in case train, if com_num is train num. Okay, in the next they're saying this com_num returns the number of common stations between this train T1 and T2. Sorry, T and T2. Okay, so for each other trains they are checking if there is any common element, they are incrementing the count value. Finally, they are saying if count of length of keys trains, what it is saying. Okay, let me. I think I was missing something in question. And to at least one common station between all of the trains. Okay, yeah. So first one is correct. The second one is checking some extra things. So it is also correct. They are checking for all these
It is
all
given.
the stations.
It is given in the question that common with all other trains. At least one common station with all other trains. So that means it should have some common station with every train in
Every
the
train.
case. That's why it's checking for length.
Okay, okay. Yeah. Okay. So that's why here, if sometime at any point in time, this kj is equal to 0, that means there is no common element, it is returning false. So for the first one, I can think in this way that if someone asks you, check some check in a broader domain and tell if some element is present, or okay, let me how to tell me. Okay, this is not the correct framing. Okay, so if someone asks you to check something and return, you can check the opposite of it. If the opposite condition matches any time, you can. Okay, I was not able to frame this. How to explain? Yeah, this basically whenever there is no common element, it is returning false, because they're saying for each of the train there should be at least one. Okay. Yeah. So if they so again here they're checking if the list contains at least one element, then they're counting incrementing the count, and finally checking if the count is same as the length of the keys. So basically, if this count is less than the length of the key, that will that meaning that there is some train for which there is no common stations. I hope you able to follow. So okay, let's see what is the correct answer, which is the above procedure was is indeed. So I think both of these are fine. Yeah. Okay, so it is already 8:15. Thank you for joining today's session. This is the last question, right? Thank you, everyone.
Thank you, sir.